Good day, engineers. Para sa video natin ngayon, ang i-discuss natin will be a sample problem for the ultimate bearing capacity of eccentrically loaded shallow foundation. Sa sample problem na to, ang i-discuss natin will be a two-way eccentricity for a square footing. So, simulan na natin yung discussion on this sample problem. So our sample problem number 2 states that a square footing is 3 meters by 3 meters, which settles at a depth of 1.8 meters from the natural grade line. So the superstructure transfers an axial load of 550 kilonewton, a moment about the x-axis which is 440 kilonewton meter, and a moment about the z-axis which is negative 247.5 kilonewton meter. So the soil where the footing is embedded has a dry unit weight of 15 kilonewton per cubic meter, a saturated unit weight of 19 kilonewton per cubic meter, and a cohesion of 25 kilopascal and the angle of internal friction of 27.5 degrees. If the water table is at a depth of 2.3 meters from the natural grade line, determine the allowable bearing capacity using the Meyerhoff's and Bowles methods. So assuming that the positive z-axis is pointing down and the positive x-axis is pointing to the right. So para ma-solve natin tong problem na to, syempre, ang una natin gagawin is to draw the figure na ini-state dun sa problem. So sabi dito, we have a square footing, so 3 meters by 3 meters, and yung footing daw na yun is nakabaon at a depth of 1.8 meters. So from this figure shown here, makikita natin, ito yung depth of the footing natin, which is 1.8 meters. Now, mamaya na natin intindihin yung tinransfer sa kanyang load from the superstructure. So, the soil where the footing is embedded has a dry unit weight of 15 kilonewton per cubic meter. So, ito siya. A saturated unit weight of 19 kilonewton per cubic meter. A cohesion of 25 kilopascal and an angle of internal friction of 27.5 degrees. So, yan na yung mga given natin. Sabi din dito, the water table is at a depth of 2.3 meters. So, ibig sabihin, yung water table natin from this natural grade line, ayan siya. So, it is at a depth of 2.3 meters. So, we have to determine the allowable bearing capacity by using the Meyerhoff's and the Bowles method, assuming that the positive z-axis is pointing down and the positive x-axis is pointing to the right. So dito, sinabi na niya na nag-transfer ng load yung superstructure na P, which is equivalent to a value of 550 kilonewtons. Nag-transfer na din ng loads na moments which are moment about x, which is 440 kilonewton meter, and a moment z, which is equivalent to negative 247.5 kilonewton meter. So ngayon, ang kailangan natin is to determine ano nga ba yung magiging direction nitong moments na to dun sa footing natin. So, simula tayo dun sa moment about the x-axis. So, makikita natin na positive yung sign ng moment. So, ibig sabihin, kapag ginamit natin yung right hand rule, kailangan yung thumb natin is pointing on the positive x-axis. So, since sabi niya dito, we assume that the positive z-axis is pointing down and the positive x-axis is pointing to the right. So, ibig sabihin, ito yung z-axis natin, ito yung x-axis. So, as you can see, yung right hand natin is ito. So, pointing to the thumb. Or, yung thumb natin is pointing on the positive x-axis. So that means ang rotation niya is pag ganito. So this will be the moment x. So yan ngayon yung ating moment x. So as you can see here in this figure, nailagay na natin siya for this moment x. So the next one is a moment about the z-axis. So about the z-axis. So as you can see, meron siyang negative sign. So this is a negative moment. So para magawa natin or malaman natin kung ano yung rotation nung moment about the z-axis, so ibig sabihin negative siya. So using our right hand, yung right thumb natin will be pointing on the negative z-axis. So kung ito yung axis na positive na sinabi niya or yung global coordinate axis na gusto niyang mangyari, so ibig sabihin ito ipapoint natin yung thumb natin doon, and yung curl nito yun yung magde-determine paano yung rotation. So ibig sabihin the rotation will be pa ganyan. So as you can see, naging pa ganito yung rotation natin. So dun malalaman yung rotation ng moments for our given problem. So ngayon, as you can see, yung arrowhead nung both moments are pointing on this side. So ibig sabihin, diyan tatama or diyan sa quadrant na yan, dito sa quadrant na to, nandyan yung actual load natin. So to convert that one, ito yung lalabas na figure. So as you can see, ito yung actual load natin. So meron tayong eccentricity along z at meron tayong eccentricity along dx. So ngayon kailangan natin i-determine ano yung values nung eccentricity na yon para magawa natin yung effective area at ma-determine natin yung effective width and effective length. So to determine E sub x or the eccentricity along x, we have here mz over p is equal to, so mz will just be 440 kilonewton meter divided by the p, which is 550 kilonewtons. So our E sub x now will just be equivalent to a value 0.8 meters. So yan na ngayon yung ating E sub x. Our E sub z now will just be equivalent to a value mx over p. So that will be yung mx natin, tanggalin lang natin yung sign. Okay naman na yun kasi that gives us the rotation lang. So kunin lang natin yung numerical value niya, which is 247.5 kilonewton meters. So divided by the p, which is 550 kilonewtons. Now determining this one, we can have an E sub c equivalent to a value of 0.45 meters. So ngayon, hindi pa natin pwedeng lagyan ng notation whatever is b prime, whatever is l prime. Kailangan muna natin makita kung sino yung mas maliit na ilalabas na dimension or effective dimensions. So, doon tayo sa pag-determine ng effective dimensions. So, nagkataon na yung footing natin is square. So, ngayon, kung rectangle man yan, ang kailangan lang natin tignan is kung ano yung eccentricity na parallel dun sa side na yon. So, dito, yung 3 meters na to, parallel siya sa EX. So, as you can see on the figure on this left side, kailangan natin siyang bawasan ng 2EX. And yung 3 meters na vertical is parallel sa E sub C. So, kailangan natin siyang bawasan ng 2E sub C. So, ibig sabihin, itong area in yellow will be our effective area. Kaya nga siya tinawag na Meyerhoff's effective area method. So, now, kunin muna natin yung 3 minus the 2 e of x. So, that will be 3 minus 2 times e of x is 0.8. So, this value will be 1.4 meters. The next dimension is 3 minus 2 e sub z. So, that will be 3 minus 2 times 0.45. So, that will be a value equivalent to 2.1 meters. So, yan ngayon yung ating effective dimensions. So, ngayon na na-determine na natin yung ating effective dimensions, we can now conclude whatever is B prime and whatever is L prime. So, whichever is lesser of the two values will be B prime and the other one will be L prime. So, therefore, from this calculation, we can conclude that B prime is equal to 1.4 meters and yung L prime natin will just be equivalent to 2.1 meters. So, yan ngayon yung condition nung ating effective dimensions. So, next natin is to determine the unit weight for the third term of the bearing capacity equation. So, as you can see on this figure, dito natin madedetermine ano nga ba yung unit weight dun sa third term natin. So, yung unit weight kasi natin on the third term depends on whatever the soil is below the base of the footing. So, as you can see, it consists of two. So, meron tayong dry soil at meron tayong saturated sa ilalim. So, sabi nga natin sa procedure on our previous topic regarding the ultimate bearing capacity for the Meyerhoff's equation, ang kunin lang natin dito is yung triangle na to. Pero ngayon, ang gagamitin natin, kasi dati this is B. So ngayon, ang gagamitin natin is kung ano man yung nailabas nating B prime. So yung 1.4 na yung gagamitin natin. So ang height din ng triangle will be 1.4. And as you can see here, we have the value D, which is the distance from the base of the footing to the water table, which is 0.5. Saan yan galing? Yung D na yan, galing lang yan sa given din natin. So, 2.3 kasi yung depth ng water table at yung depth ng footing is 1.8. So, that is just 2.3 minus 1.8. So, that will just be equivalent to 0.5 meters. So, yan na yung D natin for this one. So, yung D natin is magagamit natin to get yung tinatawag natin na average unit weight or the gamma average. So, the gamma average will just be now equivalent to 1 over B prime multiplied by, so that is just gamma dry times D, so plus gamma prime times B prime minus D. So, yan na ngayon yung ating gamma average. So, to determine the gamma average, we just have to substitute the values. So, that is 1 over 1.4 times the gamma dry, which is 15 times 0.5 plus yung gamma prime natin is saan nga ba nanggaling yan? Gamma prime will just be the gamma saturated, which is 19 minus 9.81. So that is just equivalent to a value 9.19 kilonewton per cubic meter. So ito, this is 9.19 times yung B prime natin is 1.4 minus 0.5. So, our gamma average now will just be equivalent to a value of 11.265. This is in kilonewton per cubic meter. So yan na ngayon yung ating gamma average. Next in line na kailangan nating kunin is yung overburden pressure. So for our overburden pressure, ang kailangan nating i-determine is whatever values yung naka-apply above the footing. So, ang naka-apply lang naman sa kanya is yung soil na ito. So, wala namang ibang nakapatong sa ibabaw. So, we'll just use Q, which is gamma D times DF. So, kung may thickness man na yung footing, pwede din nating isama yon sa overburden pressure sa kanya. So, bihira naman bigyan ng thickness yun. Pero kung meron pang ibang nakapatong on the natural grade line, pwede nating isama yon as an overburden pressure. So, this one will just be gamma dry, that is 15 times 1.8. So, that is equivalent to a Q equal to 27 kilopascals. So, yan na ngayon yung value ng ating overburden pressure. Next, we now need to determine the bearing capacity factors. So for the bearing capacity factors, kailangan natin i-determine si NQ, si NC, tsaka si N gamma. So let's start with NQ. Si NQ dyan will be dE times pi times the tangent of phi times tangent squared 45 plus phi over 2. So substituting the value of phi, we have here e pi or e raised to pi tangent of 27.5 degrees times tangent squared 45 plus 27.5 divided by 2. So now we'll have an NQ equivalent to a value of 13.936 kilopascal. Or sorry, this is unitless. So 13.936 lang pala siya. So next one will be NC. The NC is equivalent to a value NQ minus 1 times cotangent of phi. So that will be equivalent to NQ natin is 13.936 minus 1. So yung cotangent natin is, ang identity niya is 1 over tangent. So pwede natin gawin na divided by tangent tapos 27.5. So our NC now will just be equivalent to a value of 24.8498. So yan na ngayon yung ating NC. Then the last one will be N gamma. N gamma is just equivalent to a value NQ minus 1 times tangent 1.4 phi. So, substitute lang natin yung NQ dito and yung phi. So, that will be 13.936 minus 1 times tangent of 1.4 times 27.5. So, our N gamma now will just be equivalent to a value of 10.2898. So, yan na ngayon yung ating N gamma. So, after determining the bearing capacity factors, since natapos na natin yung bearing capacity factors, we now proceed with the shape factors and the depth factors. But before that, syempre, para ma-determine yung shape and depth factors, kailangan kasi natin yung passive earth coefficient. So, for the passive earth coefficient, so we have here Kp, which is equivalent to 1 plus sine of phi over 1 minus sine of phi. So, for this problem, ito naman yung gamitin natin. Kasi, from our previous problem, ang ginamit natin is tangent squared 45 plus p over. So, this will become 1 plus 27.5 or 1 plus sine of 27.5 divided by 1 minus sine of 27.5. So, our K sub P will just be equivalent to a value of 2.7157. And after this one, kailangan din natin yung square root of K sub P. So, that is equivalent to a value tangent 45 plus phi over 2. So, that is just equal to the tangent of 45 plus 27.5 over 2. So, the square root of Kp now will just be equal to a value of 1.6479. So, since kompleto na yung pang-determine natin ng shape and our depth factors, we'll just proceed with getting the shape factors. So, start tayo dun sa shape factors. So, sa shape factors natin, we will just use lambda CS. So, for lambda CS, we have here 1 plus 0.2. So, times Kp times, ang gamit na natin dito will be B prime over dl prime. So, that will be equal now to 1 plus 0.2 times yung K sub P natin, which is 2.7157 times B prime, which is 1.4 divided by 2.1. So, our lambda CS will just be equivalent to a value of 1.3621. So, yan na yung lambda CS natin. Next, our lambda QS and our lambda gamma S. So, this will be 1 plus 0.1 times K sub P times B prime over dl prime. So, that will just be 1 plus 0.1 times 2.7157 times 1.4 over 2.1. Calculating this value, we will have lambda QS is equal to the lambda gamma S, which is equivalent now to a value of 1.181. So, meron na tayong shape factors. Now, next will be the depth factors. So, yung depth factors natin has an equation. So, for lambda CD, that is 1 plus 0.2 times square root ng KP. Kaya natin kinuha yung square root ng KP kanina, times DF over B prime. So, this will be 1 plus yung 0.2 natin times square root ng KP is 1.6479. Times the DF, which is 1.8 divided by 1.4. So, our value for our lambda CD will just be equivalent to 1.4237. So, yun na yung depth factors natin for cohesion. Then, yung lambda QD and lambda gamma D, so we have here 1 plus 0.1 times square root ng KP times DF over the B prime. So, substitute lang 1 plus yung 0.1 times 1.6479 times 1.8 over 1.4. So, our lambda QD and our lambda gamma D will just be equivalent to a value of 1.2119. So, kung gusto nyong balikan kung paano ko nakuha tong equation ng shape and depth factors, just watch the video regarding the Meyerhoff's bearing capacity equation. So, since kompleto na natin yung shape and depth factors, we are now ready to determine the ultimate bearing capacity of the soil. So, for our ultimate bearing capacity, we have here QU is equal to CNC lambda CS lambda QS and lambda CS lambda CD times lambda CI plus QNQ lambda QS lambda QD and lambda QI plus 1/2 gamma prime or gamma average B prime and gamma lambda gamma S lambda gamma D and the lambda gamma I. So, substituting the values for these factors, so we have QU is equal to, so yung C natin will be 25, RNC will be 24.8498, our lambda CS is 1.3621, our lambda CD will be 1.4237, and especially yung lambda CI natin is 1.0 lang kasi hindi naman inclined yung loads natin. So, plus RQ and Q is, RQ will be 27 times our NQ, which is 13.936 times lambda gamma S, which is 1.181 times our lambda QD, which is 1.2119. So, the next one will be yung third term natin. So, plus 1/2 times, so we have here 11.265 times our B prime, which is 1.4 times 10.2898. Ito yung N gamma natin. Times 1.181. Ito yung lambda gamma S and yung lambda gamma D, which is 1.2119. Automatically, times 1.0 to for the lambda gamma I kasi hindi naman inclined. So, as well as this one. So, calculating this long equation, we have the value of QU, which is equivalent to 1859.4048. This is in kilo pascals. So, yan yung QU natin. Our QA will just be equivalent to QU divided by 3. So, walang binanggit na factor of safety na gagamitin, pero pinapahanap niya kasi tayo ng allowable bearing capacity. So, ang safe allowable bearing capacity or safe factor of safety for the allowable bearing capacity is 3. So, kaya 3 yung ginamit ko for the factor of safety. So, that will be 1859.4048 divided by 3 will be the Q allowable, which is 619.8016. So this is in kilopascals. So ito ngayon yung Q allowable natin. So for our next one, kailangan na natin i-determine naman yung allowable bearing capacity using our method 2. So ngayon, piliin natin alin lang ba yung mga mababago dun sa equation natin. So, ang mababago will be yung unit weight for our third term. So, baguhin natin yung unit weight for the third term. So, dito natin lagay yung calculation for the method 2. So, this is for method 2. So, baguhin natin yung gamma average. So, dito yung D pa rin niya is 0.5 meters. So, syempre, kung kanina 1.4 yun, ngayon ang gagamitin na natin dito, palitan natin to ng 3, ito papalitan na siya ng 3. So, yun yung mangyayari. So, syempre, yung gamma prime dyan, yun pa rin, yung 9.19 kilonewton per cubic meter. So, our gamma average for method 2 will just be 1 over B, so times gamma dry times D plus gamma prime times B minus D. So our gamma average will just be equivalent to 1 over 3 times the gamma dry is 15 times 0.5 plus gamma prime is 9.19 times B is 3 minus 0.5. So to calculate the gamma average, we just have 1219 over 120 kilonewton per cubic meter. So, ayan yung isa sa nagbago. Overburden pressure, hindi yan magbabago. That will just be Q, which is 27 kilopascals. Next, yung bearing capacity factors, hindi din yan magbabago kasi hindi naman nagbago yung ating angle of internal friction. So that is just NQ, which is 13.936. So double check natin yung value. So 13.936. Yung N gamma natin is 10.2898. And yung NC will be 24.8498. So, yan yung still bearing capacity factors natin. Ang magbabago will be our shape factors. Yung shape factors natin is ang magbabago doon kasi magiging B over L yun and DF over B for the depth factors. So, yung KP dyan, hindi magbabago or yung passive earth coefficient, yan pa rin yung 2.7157. And yung square root ng KP will just be equivalent to 1.6479. So, yan yung KP natin and square root of KP. Ngayon, we'll have to calculate the shape factors. So, for the shape factors, we just have lambda CS, which is 1 plus 0.2 times Kp times B over L. So, that is equal to 1 plus 0.2 times yung Kp natin, which is 2.7157, times B is 3 times L is 3. So, this will become 1. So, our lambda CS now will just be equivalent to a value 1.5431. Then, our lambda CD or lambda QS and our lambda gamma S will just be equivalent to 1 plus 0.1 times Kp times B over dL. So that is equal to 1 plus 0.1 times 2.7157 times 3 divided by 3. So our lambda QS will just be equivalent to lambda gamma S, and that is equal to 1.2716. So ayan na ngayon yung ating shape factors. Then yung last na i-determine natin will be depth factors. So that is just lambda CD, which is equal to 1 plus 0.2 times square root ng Kp times dF over B. So, substitute lang natin yung values. We have 1 plus, so that is 0.2 times 1.6479 times dF, which is 1.8 divided by 3. So, our lambda CD will just be equivalent to 1.1977. So, our lambda QD naman and lambda gamma D will just be equivalent to 1 plus 0.1 times square root ng Kp times dF over B. So, that is equal to 1 plus 0.1 times 1.6479 times 1.8 divided by 3. So, our lambda QD and our lambda gamma D will just be equivalent to 1.0989. So, yan na yung ating depth factors. Ngayon, pwede na natin kunin yung QU concentric. So, QU con na lang ilagay natin, which is equivalent to the CNC, lambda CS, lambda CD, lambda CI, plus QNQ, lambda QS, lambda QD, and lambda QI, plus 1/2 gamma P and gamma, lambda gamma S, lambda gamma D, and the lambda gamma I. So, our QU now concentric will be, lagay natin yung mga values na kinuha natin kanina. So, yung C natin is 25 times 24.898 or 8498, sorry, times the lambda CS, which is 1.5431, times 1.1977. So, the next one will be yung Q natin, which is 27 times 30.936 times the lambda gamma S, which is 1.2716 times 1.0989. So, hindi ko na nilalagay yung CI, yung QI, tsaka gamma I. Kasi 1.0 na yun automatic, hindi naman inclined yung ating load. So, plus 1/2 times B or gamma muna, which is yung gamma average. So, that is 1219 over 120 times our B, which is 3, times N gamma is 10.2898 times our lambda gamma S, which is 1.2716 times lambda gamma D, which is 1.0989, and times 1.0 pa rin to for the lambda gamma I. So, calculating the value, we have a QU concentric equivalent to 1,847.1216. This is in kilo pascals. So, yan ngayon yung concentric load pa lang natin. Wala pa yung eccentric. So, for method 2, kailangan natin i-determine yung reduction niya. So, kunin natin yung ito. So, para ma-determine yung reduction ng ating concentric bearing capacity or ultimate concentric na bearing capacity, kailangan muna nating i-determine yung ratio nung EX over B or EZ over L para dito. So, kasi cohesive yung soil. Kung cohesionless, automatic, ang gagamitin nating equation is 1 minus square root ng EX over B. So, dito, kung ano yung parallel sa kanya, yun yung ratio na kukunin. So, 3 tsaka itong EX. So, that will be yung EX over 3. So, yung EX natin is 0.8 divided by 3. So, that is 4 over 15. Or ang value kasi nito, this is 0.2667. So, this is lesser than 0.3. So, that will be considered na ang gagamitin natin is yung second equation. So, kunin din natin yung EZ over L or yung over 3 din. So, that is 0.45 over 3. So, this is equivalent to 3 over 20 or this is 0.15. This is lesser than 0.3. So, greater than sila parehas ng 0. So, ibig sabihin, yung reduction na gagamitin natin for both values will be 1 minus square root ng E over the dimension or any dimension B or L. So, dito, gawin natin will be for REX, that will be 1 minus square root ng 4 over 15. So our REX now will just be equivalent to 15 minus 2 square root of 15 over 15. So yan na yung value ng ating REX. Yung REZ naman natin will just be equivalent to a value 1 minus a square root of E sub C over L. So, yung E sub C natin will be, ito yung 3 over 20. So, 3 over 20. So, that is just equal to an REZ of 10 minus square root ng 15 over 10. So, yan na ngayon yung ating reduction. Now, getting our QU eccentric. So, the QU eccentric, so that will be equivalent to QU concentric times REX times REZ. So, that will be equal to 1847.1216 times yung mga reductions na kinuha natin, which is 15 minus 2 square root of 15 over 15 times 10 minus square root ng 15 over 10. So, yung QU eccentric natin will be equivalent to 547.3093 kilopascals. So, yan na ngayon yung ating QU eccentric. Pero, Q allowable yung pinapahanap sa atin sa problem. So, ibig sabihin nun, we'll just have to use Q allowable is equal to Q eccentric divided by 3. So, that is just 547.3093 divided by 3. Now, the Q allowable na hinahanap natin will be 182.4364. So, this is in kilopascals. So, ito na ngayon yung pinapahanap sa atin na allowable bearing capacity. So, that is all for the sample problem regarding a square footing with two-way eccentricity. Hinanap natin yung yung allowable bearing capacity niya for the Meyerhoff's effective area method and for the method 2, which is yung gumagamit tayo ng reduction. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.